Alright, in this video we're going to talk about Algebra 2 transformations. We're going to specifically talk about dilations and what dilations do. Before we go into any examples, I want to give you guys the generic forms of what's going to happen. So I confuse you really quick first and then explain what happens. So, confusing. If I have C of x is time, or C of f of x compared to f of x, when C is greater than 1, what that's going to do is it's going to stretch it, and it's going to stretch it vertically. So this is going to stretch vertically. Notice that the C is outside of the actual function. When C is between 0 and 1, it's going to shrink vertically. All right. Now when I have that C inside of the function, when f of C of x is compared to f of x, when it's inside the function, when C is greater than 1, it's actually going to go backwards from what you would think. And this is going to shrink it, and it's going to shrink it horizontally. All right, and when C is between 0 and 1, this is going to stretch, and it's going to stretch horizontally. And they're going to go by factors, and the factors that they're going to go by, so when we're looking at when it's on the outside, this is going to be stretched vertically by a factor of, and you're going to use the absolute value of C. And it's going to be shrunk vertically, I should say, by a factor of, and again, here's where you're going to have to look, and actually it should just be the factor of C. Factor of C. And for this one, since it's being shrunk, you have to think opposite, and you're going to have to be shrunk by the, or you're still going to go shrunk by the factor of C. And for shrinking horizontally, you have to think opposite. So it's actually going to be a factor of 1 over C. And the same thing for when you're going stretching horizontally. All right, so one more thing to confuse you guys, and then we'll explain, do some examples. When it's a negative on the outside of the f of x, what this is going to actually do is this is going to reflect about the x-axis. So it's going to reflect over the x-axis. When you're looking at the one where it's inside, this is going to reflect over the y-axis. I don't know why I'm doing my r's like that, but it's going to reflect over the y-axis. So I understand this might be a little confusing. Make sure you have that down in your notes so you guys can see what we're talking about here when we go and actually do this. So let's look at this problem here. First thing we want to do, just like we did when we were talking about just transformations, is I want to go and I want to know what is my parent function. So let's think about what our parent function is going to be for this. Our parent function is f of x equals x squared. Again, just looking at that x squared. So we're going to go and we're going to plug in our basic x squareds into our table here. But before I do that, I'm going to go and I'm going to look at this piece here. Is that on the inside or is that on the outside of that squared? Well, that 2 is not being squared, so it's on the outside. So that means that this is going to be a vertical, and since it's greater than 0 or greater than 1, it's going to be a vertical stretch. And it'll be a vertical stretch by a factor of 2. All right, let's look at this problem. So again, parent function. Our parent is f of x equals x squared. Now we're going to look at where that 4 is. That 4 is what's changing it. That 4 is on the inside. That 4 is being affected by the x squared, or sorry, by the squared. So that means that it's on the inside, which means it's horizontal. It's horizontal, and you have to think backwards here because it needs to be horizontal, and it's in the inside, so it's going to be a horizontal shrink. It's going to be a horizontal shrink for this one. All right, now what's our parent function of this one? Well, our parent, again, is f of x equals x squared. What's the difference? What's changing here? That negative. That negative, is it being affected by the squared? No, it's happening after the squared. That means it's on the outside. That means it's a reflection first because we see that negative. It's a reflection and it's over the x-axis because it's on the outside. Reflection over the x-axis. All right, now we have to look at this. What's our parent function again? Our parent is f of x equals the cube root of x. What's the change in this? Our change is right there. And since that's on the inside, it's a reflection over the y-axis. All right, I have three more things I want to talk about before we go and start actually graphing these things, or graphing these. First thing is, let's look at this. How many different changes do we have in here? Well, we have really two different changes. The first change is that negative, and that negative is on the outside. Well, again, first, what should we do? Our parent is x cubed. So our first thing we know is the negative, so we know this is a reflection. It reflects over the x-axis because it's on the outside. And we also notice that it has that 3 on the outside. That 3 again is on the outside, so it's a vertical. And since it's larger than 1, it's a vertical stretch. It's a vertical stretch. All right. What's happening to this one? Well, we only have that outside, and that means that that's going to be a vertical stretch. And last but not least, this one we have it on the inside. It's on the inside there. So since it's on the inside, we know it's horizontal. And since it's actually, really, this is the same thing as f of x equals the step function of 1/2 x, we know that that is less than 1. That means that it's a vertical stretch. And it's a vertical stretch, really you're going, or sorry, horizontal stretch, you're going by a factor of 2 there. All right, so now that we know what's happening, let's go back and let's actually graph these and see what the difference is. So our parent function in this problem is f of x equals x squared. So let's put in our actual parent value. I think you guys are starting to see why I'm telling you should memorize those parent xy's. So now what's going to happen is it's a vertical stretch. It's on the outside. Since it's on the outside, that means it's going to affect our y values. So really what we're going to do to our y, since it's on the outside, we're going to multiply by 2. It's a stretch, so we're multiplying. So I'm going to multiply each of my y values by 2. So 8, 2, 0, 2, 8. Now I'm going to graph both my parent function and my new function. And remember, our new function, we're going to be using these two pieces. So let's graph those both. All right, if you guys notice, my red one is my parent function and my blue one is my new function on there. You guys can see that my new function is really becoming a lot more skinny. It's beginning stretched out, which means it's getting skinnier. That's what we want. When it's on the outside, it's going to stretch it. It's going to make it skinnier. When it's greater than 1, I should say. When it's between 0 and 1, it's going to actually make it fatter, wider. So we'll show some examples of that in a second here. Now this one's on the inside. So again, I'm going to go and I'm going to fill in my parent function values here. My parent function values, -2, -1, 0, 1, 2, 4, 1, 0, 1, 4. And since it's on the inside, it's actually going to be affecting our our x values. Inside affects our x values, just like with translations. And again, just like translations, we have to think opposite of the inside. So since it's really multiplying by 4, we're going to divide each piece by 4. So divide each piece by 4. So I'm going to divide by 4, and we end up with, well, this is going to be -1/2, -1/4, 0, positive 1/2, 1/4, positive 1/2. Now I know what you're thinking, we're seeing fractions. Everybody hates fractions, right? Well, let's make life easier. Instead of going by ones on our x values, let's go by, I don't know, let's go by fourths. So I'm going to go by fourths here. I'm going to make it 1/2, -1/2, -1, -1 1/2, -2, and then 1/2, 1, 1.5, 2. Now I'm going to graph both my parent function and my actual function here, and I'm going to show you again, these are my x's and my y's for my actual function. Alright, so you guys can see by my graph there, the red one is my parent function. It looks a lot wider because of the fact that I changed my scale. My green one is my new function. You can see my x's are getting really, really close together. They're bringing those closer together. That's what they're doing. They're horizontally shrinking it. They're bringing my x values closer together. My change in x is becoming less. Alright, I know you guys love watching me graph these, but I graphed that one on my own. This parent function, without you guys seeing it, I apologize. I know I'm breaking your guys' hearts. But, so now we need to do reflection over the x-axis. X-axis. Well, that makes you think, oh, I'm going to change my x values. Well, no, because it's on the outside. It's really on the outside. What we're going to do is we're going to multiply all of our y values times -1. So really, it's going to become -4, -1, 0, -1, -4. It's on the outside, so we're really multiplying our y values. And what ends up happening here is we'll end up getting 0, 0, and you'll end up getting your parabola to flip over your x-axis. So when it's on the outside, it's going to flip it over the x-axis. Now when we're on the inside, it's going to reflect over your y-axis. So let me graph those again quick. So again, remembering our rules of parent functions, our the cubed root of x, our x values are going to be -8, -1, 0, 1, and 8. And what we're going to do since it's on the inside is we're going to still multiply it by, well, really you could do the opposite if you want. You can divide by if you want. But we're going to multiply by -1. So our x values are actually going to become 8, 1, 0, -1, -8. So really they're flip-flopping. So now the first point we graphed on this one was here. The next one we're going to graph, the first point we're going to graph is right there. Notice where it flips. It flips over your y-axis. Now our second point that we would graph is right there. And the next one second one we're going to graph when we're graphing our new function is right there. Again, flips over the x-axis. So you can see that's what's happening is that it's flipping over your, sorry, not your x-axis, your y-axis. This is flipping over your y-axis. These 2 points go together, and these 2 points go together. We're flipping over our y-axis. So when it's on the inside, it's going to flip it over the y-axis. Now let's try two things happening to it. So this is happening on the outside. All of it's going to change is my y values, and we're going to flip it, and we're going to multiply by 3. So let's do that quick. Let's graph the parent. I'm not going to graph my parent yet, but I'm going to show you the steps of what we would do to change our y's. Now you could do this in one fluid motion, that's fine, but I'm going to do it piece by piece. First I'm going to do is I'm going to multiply my y's by 3. And it's on the outside, so we're affecting our y's. So it goes 24, 3, 0, 3, 24. Now we're going to also multiply by -1 because of that negative piece. So it's -24, -3, 0, -3, -24. So our new values are -2, -24, -1, -3, 0, 0, 1, -3, and 2, -24. Now if you notice, my y's get pretty darn big. So what I'm going to actually go by on my y values, my y-axis, is I'm going to go by 3's. So I'm going to go 3, 6, -3, -6. So now you know I'm going by 3's. I'm going to graph that one quick for you. So here's what our next graph looks like. So I'm going to leave these last ones for you guys to graph. Practice graphing those on your own. They're the step function ones. I'm not going to do those ones in the video. You guys can try to look those up online if you want to, or you can ask me when I see you guys face to face. Otherwise, that's the end of this video. Make sure you watch the next video. We're going to put them together. We're going to dilate and we're going to translate at the same time.